I want us now to think back to when we were doing parabolas, right? When we were doing parabolas. So I'm up to the next example now. You guys are sick of this, but I'm going to use it anyway, okay? Let's think about the domain of this first, right? Because we've been looking at the domain a bit earlier. What kinds of values of x are off limits to this equation? Are there any values of x that I put in there and things just blow up and stop working, like over here? Can you put in 0? Is that going to work? You can, right? You'll get 0 squared plus 5 lots of 0 plus 6. You'll just get 6. Can you put in really big numbers? Yeah, there's no limits. Can you put in small numbers? Really negative numbers? There's nothing that's going to cause you problems, like over here. Okay. So how do I state its domain if it can go anywhere? Do you remember I gave you a definition for this? Being that I can put in anything, I will say all real values of x. Okay. Now you might say, why do I have to put that word real in there? It's a bit of a teaser for the fact that there are other kinds of values of numbers that aren't real, and you can learn about that in future years, but that's the way I state this. Okay, now when we get to range, things get a little sneakier, okay? Y equals x squared plus 5x plus 6. Let's get a really brief picture of this. If you factorize it, what would you get? X squared plus 5x plus 6. Got a pair of numbers, add to this, multiply to this, what's your pair of numbers? 2 and 3, right? So this is my factorization. Do you agree with that? Once I factorize it in this way, I can read directly off it what the roots are, right? When y equals 0. What are the roots of this now that I factorize it? Yeah, it's the negatives, yeah? Negative 2, negative 1, negative 2, and negative 3. Those are my two roots, yes? Okay. Now, parabolas are either happy parabolas, facing up, or they're facing down. Is this one a happy one, or is it sad? Is it frowning? X squared plus 5x plus 6. What value tells me whether it's happy or sad? It's actually, this is a happy one, right? The way I know is it's the number out the front here, the number attached to x squared, okay? In this case, it's positive 1. So since it's positive, it's going up. Okay? So this is roughly what it's going to look like, okay? Now, let's just have a look at this first in terms of domain. Can you see? It just goes everywhere. I've got none of these weird dotted lines that are breaking my function, okay? That's why the domain is all real values. Everything's sweet there. But there are some values of y I can't get. Do you see that? Some values that no matter what x you put in, I won't be able to go there. For instance, like down here, whatever this value is, okay? I can put in x equals 0, x equals 1,000,000, x equals minus 1,000,000. I'm never going to get underneath here. So the question is, what's the lowest point on this parabola? That's as far as I can go. It has a name. It starts with a V. Does anyone remember it? Vertex. It's the vertex, right? If I can find where the vertex is, the vertex, that's the lowest point, and I can't ever go below that, right? Or if it was a sad parabola, there'd be that highest point, and I can't ever go above it, right? Does that make sense? So all I need to do is find where that point is. Okay. Now I'll save you a bit of work. I happen to know where this one is because I pull out this example all the time, right? The coordinates of this this vertex are minus 2.5. That's the easy spot. How do I know that the x value is minus 2.5? It's the axis of symmetry, right? So it's right between the two roots. Minus 2, minus 3. That's got to be halfway, right? And I'm 99% sure that if you pop it in, you'll get y equals minus 1/4. That's where the vertex is, okay? So if that's where the vertex is, that's the lowest possible point. What does that indicate about range? Where can I go? Yeah, it's there and above, right? Y equals negative 1/4. That's the lowest I can go, and I can go anywhere above there. Do you see how this is a reflection of, well, how much of the graph, how much of the Cartesian plane can I go on, right? And the answer is there and up. Okay, does that make sense? Okay, so I want to draw your attention now, if you haven't already, to look at page 588, and you can see there's a few sneaky examples there, right? So for instance, let's pull out, let's have a look at a question like part I. Can you see part I? Right, so it looks like this.
So,
yes?
I have a doubt. So you say that all real values of x, right?
Yes?
So you can just say any value of x.
Effectively, yes. You can pick any value you like, and I'll be able to go there. I can input it, and it will work. All right, now I'm really quickly going to sketch I, okay? And maybe you want to have a basic sketch. It doesn't have to be beautiful, okay? Just enough to work off a little bit. It looks like this. This is part I. And that value is -2, I think it is. Okay, now, what is this thing? As it happens, I don't need to know what the equation of this thing is to work out what its domain and range are. I just need to look at it, okay? If you're curious, it's an exponential. It looks to me like it's 2 to the minus x minus 2, but the equation, like I said, is not important. Just look at the thing, right? Firstly, let's talk about domain. What values of x are okay? Where can I roam? Or alternatively, where can I not go? Are there any spots that break the function? Are there any spots that break the function?
-2.
Yeah, -2.
Now, I'm just thinking about one step at a time. I'm on domain, right? We'll get to -2 in a second, right? Now, domain is horizontal, right? Do you remember, alphabetically speaking, domain comes and then range, which means this is x and this is y. So this is horizontal and this is vertical. Now, horizontally, I can go anywhere I please. Do you see that? There are none of these weird vertical lines that are breaking things. Alternatively, the graph never stops, right? It's not like I said, oh, there we go. There's a spot and I'm finished, right? That arrow indicates it goes and it goes forever, okay? So being that I have an arrow there, I'm going all the way over that way to the left. I'm going all the way over this way to the right. Everything's fair game. There's no holes in it or anything, right? So therefore, I can say the domain is all real values of x. They all check out, okay? Now when we get to range, things start to get a bit sneakier. This -2, this is the problem, okay? Now, don't forget, by the way, this is a horizontal line, so what's its equation? Y equals -2, okay? So that's where, do you notice it's dotted? Right? That means I'm never going to get there. I'm never actually going to reach it. I'll get very, very close, but I won't touch it, okay? So is y equals -2, is it part of the range? Is it a value I can actually get? And the answer is no. That was the whole point of saying I'll get closer and closer and closer, but never actually reach it, right? So I'm not there. Am I above or below?
Above.
I'm clearly above, right? So that means greater than, right? So I would say y is greater than, not inclusive, so I don't have an extra line there, greater than -2. I'm just reading it off the graph, okay? Now, you can see, if we have a look at L, which is a bit sneakier, so this is I, right? L, let's draw a really, really brief graph. Looks like this. Okay, forgive my messiness. Okay. Now, domain. I'm just gonna go past this. Is exactly the same as our previous function. It's any value. You can put them all in. The arrows tell me I'll go forever, and nothing stops me. So that's what the domain is. All real values. But when you have a look at range, again, there's something a little more interesting, right? For starters, this dotted line. I don't think they've indicated even the dotted line, but you can see it's kind of implied by the shape of the thing, right? What's the equation of my asymptote, my dotted line in this case? It's horizontal, right? So it's y equals something. And it looks to me like it's right on the axis. Yeah, right on the axis. So that's 0, yes? Can I get to y equals 0? I can't. There's nothing on the picture that tells me I'll ever get there. I'll get very close, but I won't get there, okay? So I won't get to 0. But I'm not just anywhere above, right? There's also an upper limit that I can't go past, which is, looking at the graph, 4, right? Now, can I get to 4? I can get to 4, right? In fact, that's exactly where I pass through. So therefore, I would say y is greater than 0, right? But simultaneously, it's got to be less than or equal to 4. Less than or equal to 4. Now, do you notice, remember I pointed out, These are or, right? Or, because you can't be both at the same time. There's no number you can come up with that does all of these, right? But there are loads of numbers that are greater than 0 and less than or equal to 4 at the same time, aren't there? Like 1 is fine, 2 is fine, it's both of those at the same time. Okay? So just like I did here, I'm going to encapsulate these into one inequality rather than two separate ones. I'll say 0 is less than y, which is less than or equal to 4. This is another way of stating exactly the same thing. Just note, please be careful. Here, I don't include 0. That's why there isn't a little extra line to indicate equality. But here, I include 4. Right? So we call these boundary values, like what are your edges? You can't get to this boundary, so it's not included. But you can get to this one, so that's why it is. And those are really sneaky. Okay?